This is RFGEN44, a portable RF signal generator, your key to hassle-free RF signal source. If you work with RF, you always need an RF source, and your options have been always very limited. RF generator instruments sometimes cost hundreds, if not thousands of dollars, and you are specifically locked to vendor-specific software for controlling them. As a solution, I designed this RFGEN44. This is highly compact unit, small form factor with two RF source output on the front, USB-C and aux IO on the back. There are status LEDs both in front and back. The aux port can also be used for external reference, internal reference, and as sync IO. Device supports standalone operation without needing of a PC. If it is programmed, you will immediately see RF signal as soon as the device is plugged in. We are using a SMA to BNC adapter to plug into BNC input of my spectrum analyzer. This is the PCB of the generator. It shows you the MCU on the left, analog devices PLL on the right. In the block diagram, you will be able to see exact details, what are the features and what is located where. You can also see what is the aux port capability on the left. As said, I have configured 100 MHz standalone operation and the device automatically turns on without needing of a PC. You can see the clean 100 MHz signal being displayed. Here's the view of the software. It is an open source software based on Qt. You can modify this software according to your need. We also provide open source Python library so that you can control this device with your own tools, with your own software, within your own environment. Device can of course also be controlled by scientific applications in LabVIEW or MATLAB. Now you can see on the screen, I have programmed the sweep 100 MHz to 200 MHz with step size of 10 MHz. Right now it's quite slow because the step time is set to 500 milliseconds. You can change the step time to make it faster. Now this is the view of macro programming window. You can program a few macros, enable, disable the output, change the frequency with specific step size, and also insert delay according to your need. Device can support executing macro directly in device or using control software. Detailed documentation is available on the website, and multiple YouTube demonstration videos are also available. This macro feature is really useful for the presence beacon and ham radio people who need to repetitively execute certain tone transmission for various purposes. Now we will test some high frequency stuff at around 2 GHz. Let's turn on the output. And now I'll program a sweep so that you can see that similar function with different frequency. It supports up to 4.4 GHz and works reliably well. Let's look at the signal timing stability, how precise the signal timing is. So we'll use our high-end Keysight 53220A frequency counter to see how precisely we can adjust the frequency. You can see now I'm adjusting frequency in 10 kHz step, which is clearly visible on the frequency counter display. If needed, device supports external clock input on the aux pin, so you can synchronize this device to an even high precision oscillator such as rubidium or GPST oscillator for exact clock and timing performance. For more information, visit website www.circuitvalley.com.